So, David, I actually followed what you asked me, tried to see what avenues we can look into for bringing this new development into the codes and standard. So I look at it from industry perspective and the ASC committees I serve on. So first, frankly, I've been uh, in contact with this development for a number of years, and I see significant progress actually. It wasn't too long ago we could only analyze the model for half a hertz or 1 hertz. Now with better solution, efficient algorithm and computer power expanding continuously, I believe we have reached 10 hertz or maybe more than that. Pretty soon we are going to cover the full range of frequencies that we are interested in engineering. As you know, in the East Coast, uh, frequencies goes up and up to 50 hertz or so before we get to the peak ground acceleration. So it depends on the location. So I do see some promising notions from this approach that could even help what we are doing right now and improve it. And I'd like to point to those points. Uh, First observation is, as was discussed and presented by many speakers, this approach requires tons of data, starting from fault and fault rupture to regional geology, topography, geophysical data for the whole region. And every time we deal with data, we have variability. Some of them are natural variability, some of them we just don't know. And we have to deal with that. And I'll give you an example. I happen to be working on a project this week in a state where we have not done any site-specific PSHA work. So I decided to use USGS, seismic map. And I used both 2014 and 2018 maps that have been published. I came up with the spectra. Then I said, let's compare it, USGS, with the two other sites where we do have PSHA done. One in the east and one in the west. We have to see that comparison. It's vastly different. At one site, one is significantly higher than the other. At the other side, it's significantly lower than the other. And it really speaks to how aleatory epistemic uncertainties are handled in this ground motion calculation. And when you look back at this data set that is needed, the handling and simulation of variability becomes pretty important. And of course, you always need the judgment of experts, and in this case would be experts from geoscience areas and seismology, multiple areas that have to provide a sound judgment actually as to how you process these variabilities. I think I may be repeating norm here, but I do see verification and more importantly, validation, the key here. The more we can correlate with the data we have with the fault seismic setting and rupture that we have recorded motion for, the more it's going to shine, frankly, and perceived by the community. So I know we have done some, but the more we do, the more weights it really adds to this new methodology. Now with that, let me tell you what we do in the industry for critical facilities and see how we can come in with this new approach. In a nutshell, in one slide, typically we do a PSHA work under a highly regulated shack process. Usually shack level 3 is used. What they do, they often come up with a hazard at a basement rock, which could be at shallow depths or at very deep depths at the site. Then we go through another rigorous process of site amplification to transfer the hazard from rock to the elevation in the soil we are interested. Then we have to assess this spectra we are getting at multiple depths and look at the cliff, if you will, in the hazard curve, make a correction to the spectra to go from uniform hazard spectra to design spectra. So there are multi-step process to arrive at the spectra. We have abandoned, as you know, performing vertical site response analysis. In the previous workshop, Pierre, you and I presented some results that showed anomalies associated with P wave propagation. So currently industry using empirical relationship for V over H. So once you have the horizontal spectra, you convert it to the V, vertical spectra. Once these are set, and if you choose to do time history analysis, then now they require you to develop 5 sets with very specific criteria for matching, and also looking at the energy content in PSDF of these time histories. And after all that, you can then apply it to the analysis. So with that process in mind, at least for critical facilities, I see few opportunities that this new development can help. This is going to be a step by step. It's not going to be, in my view, that at this time, with limited V and V, people will say, okay, we use this approach, we get the motion the spectra, and we are done. It's going to be step by step over a number of years. One of the things that I personally have been bothered by is the assumption of the wave field. When the fault ruptures, and I have seen some results showing how the wave propagates toward the site, whether they are all actually vertical waves, surface wave, other body waves involved in this, we don't quite know. Once we get the hazard at the site for the basement rock, we simply use vertically propagating wave to amplify that motion to the soil. This assumption is likely to be very conservative, especially if you're not too far away from the fault. And I think that can be looked at in relative sense and see whether we can capture the nature of the wave to some extent at different distances from the fault, and whether the assumption of vertical propagating is a good assumption or not, or overly conservative. We have given up on vertical spectra approach. We don't believe in P wave anymore. In fact, some of the researchers believe that most of the vertical motion is caused by reflection, refraction of shear waves coming in an angle that cause the vertical motion. I think that can, this approach can help really to shed light on the nature of the vertical motion and see what is causing that, what is behind that. It cannot be P wave, all pure P wave. We already know that pure P wave has come and gone before we see the shear wave. So it's something else. And that can be helpful there. So I think, as I said earlier, the codes and standards committees are receptive for a study that well-researched, well-founded, and can fit into the performance goal that they have in mind in the standard. So I think these areas, we can provide the studies that show that some of the assumptions we are making are not truly realistic. They are going to be receptive in light of doing these analysis for the site to allow other considerations, frankly, for development of the design spectra. Yeah, I think that is all I have. So I see avenues for this development to come in. I do emphasize validations is very important. It goes a long way to even pick up this idea, frankly, by different code committees. And then I think people can champion these various elements to wedge into the standards and codes and go from there. I think that's all I have, David.
Thank you. That's very, very helpful from that perspective. Any panel comments on this, or any comments from the audience? You could inject them into the Q&A.
Yeah, David, should we promote anyone who is interested in audience to the panel so we can have an open?
Yeah, absolutely. If somebody wants to chime in and raise their hand, I
Yeah.
think it's a game in this
Uh,
session.
yeah, please raise your hand, and we'll open up things so you can speak, open your video, anything. Anyone in the attendees, please go ahead. And there was a comment from Swami Krishnan. Khalid, you can see it in the thing. Actually, I can give
Yeah.
him permission to talk so he can ask directly.
Yeah, that would be fine. Yeah.
Yeah, I just saw it. You want me to read it or he's gonna read it?
We can ask Swami. You can unmute and you can ask your question or comment.
Oh, I can read it.
Yeah. Mhm.
It's actually not a question. It's a comment. He says, I think peer taking the lead in developing, hosting, and curating a simulated ground motion database is extremely positive development. This will greatly enhance the chances of buy-in within the practicing engineering community. As we all know, data from large earthquakes in urban regions is sparse, and preparing for these events, getting our building stock updated